Welcome, and thank you for joining us. This series of events is convened by Northwest Food Processors Association. It's sponsored by Northwest Energy Efficiency Alliance and produced by Emerging Tech Accelerator. You're in good company today. Here's a partial listing of the companies that have registered to attend. And here's how the next hour or so is going to go. We're going to start with an expert panel. We'll follow that with a featured manufacturer presentation, and then we'll bring the panel back to follow up and ask questions of that presenter. Your questions are welcome at any time. Just use the little chat window down on the right side of the screen. So, where did today's content come from? Well, we worked for the pilot team of NWFPA members. They prioritized problems and opportunities for which externally developed innovations might be a solution for the entire membership. For each of these opportunity categories, Emerging Tech Accelerator does a worldwide scan and identifies 50 to 100 solution possibilities. These short lists are then studied and ranked by the pilot team, and then we invite the top-ranked innovators to present in this forum. I'm going to introduce the panel in just a moment, but first, here's a list of topics we'll be covering with the panel. If there's something you want to cover that is not on that list, don't hesitate to ask, just use the chat screen. Okay, let's introduce the panel. Representing robot manufacturers is Jonathan Farrell of ABB Robotics. ABB is based in Basel, Switzerland, but Jonathan works out of Denver, Colorado, where he can sometimes be found doing time and motion studies on a big bike. Representing system integrators is Ken Tennell of Bastion Robotics. Bastion is in Maryland, Missouri, a suburb of St. Louis. Representing the CapEx decision, whether to buy a robot or not, is Charles Goulding of R&D Tax Savers from Syosset, New York, a few miles south of Oyster Bay on Long Island. And also, let me introduce our featured manufacturer, Jack Yule of Yaskawa Motorman. Yaskawa is from Kitakyushu, Japan, but Jack is from Cincinnati, Ohio, home of the Skyliner.
All right, well, thank you very much for the time today. And actually, the panel did an excellent job highlighting and underscoring a lot of the new technology developments within the food processing and food packaging environment. I'm Jack Yule. I'm the sales manager for Yaskawa Motorman Robotics, specifically our consumer products group. We are headquartered in Miamisburg, Ohio, just south of Dayton. And I'm very eager to share some of the technologies that we see at Yaskawa Motorman that are influencers and technology advancements within food packaging and processing. First, a little bit about who we are at Yaskawa. We are a 100-year-old company. Most people know us for anything that moves. We are considered motion experts. We have 3 different groups within Yaskawa: Motorman Robotics, and then our drives in motion, which are drives, and everything motion related with servo controls. Headquartered in Kitakyushu, Japan, we've got about 15,000 employees, but we are a very centric U.S. operation. Our headquarters is in Waukegan, Illinois, outside Chicago, which is the building on the lower left. And our Motorman headquarters, again, is in Miamisburg, where we house about 500 employees. And we control everything robotic from Canada through South America. Globally, we have facilities in 25 countries on 6 of the 7 continents. It provides support from engineering, applications, product development, assembly, and integration. So virtually, since most of our food and beverage organizations that we support are global entities, we provide that global support as well. But we expand certainly beyond the food and beverage industry. We have a presence in virtually all the industries from aerospace to medical, pharmaceutical, certainly heavy industry, agricultural, as well as consumer goods. So let's start by understanding a little bit about robotics and food and packaging. This particular data illustrates a rather alarming trend within consumer packaging, and that is the growth of robotics. If we look at this and understand that we segment this into two different areas, the blue is representative of end-of-the-line automation, which is palletizing, and then the red signifies upstream automation in robotics, which is pick and pack. So it's your processing and your initial packaging. But what's interesting to look at is just in a very short term, over a 4-year period, we can see a very drastic increase in the deployment of robotics within each sector. Specifically in pick and pack, the robots have been deployed almost threefold in just over a 4-year period, and just shy of a threefold increase in the palletizing segment. So we take pause to understand that all of you and your peers are really taking a serious look at robotic deployment within the food processing and packaging environment. Next slide. When we look at the statistics in technology within the growth in packaging in consumer goods, PMMI is a leading organization that most all of us are aware of. They did a great study and reached out to thousands of members, which include food and beverage processors like yourself, as well as other end customers and OEM and equipment suppliers like Yaskawa Motorman. The key technology bellwethers for the next 5 years are listed here in this summary. What's very interesting to see is we're looking at an involvement in technology spanning the spectrum between the obvious choices of increasing the speeds of the robots to decreasing the cost of the robots, which we all understand is an evolution. But what's really kind of interesting is point number 2. Most of the customers have realized that the robotic applications need to migrate to integrated robot controls, more of a unified approach. And the good example is our smartphones. We have embedded multiple technologies, multiple hardware within one device to make it user-friendly. This is a trend that Yaskawa Motorman has realized. We've listened to the customers, and the next slide will indicate some of the future involvements of that technology. We've defined the unified control architecture at Yaskawa as the MLX. And what this means is we allow the robots to be programmed and controlled through a central PLC. In this case, it could be a Rockwell PLC, but it could be a Yaskawa motion controller. It could be another brand of PLC. Ultimately, our gateway technology allows all the kinematics of the robot to be handled through our unique processor platform. But the operator interface and the programming of the cell is a very well-known ladder logic format, which is within the PLC. Next slide. This architecture summary further describes how simple this solution is. Conventional robot deployment utilized a robot controller that would in turn then tie in and try to communicate to the PLC. What you ended up with were redundancies in 2 separate processors, the robot controller and the PLC, and 2 separate languages. The language in the PLC, which is a ladder construct, and the language from the OEM robot controller, which is its own unique language. This redundancy is what customers are echoing that really should be eliminated. The PLC should be, by nature, the heart of the line. And Yaskawa Motorman has developed this solution. Specifically, we provide our gateway module, which is the heavy lifting of the robot kinematics, but a simple Ethernet connection to the PLC allows control logics, RS logics, to program the actual robot architecture. This is a unified solution, very simple, very cost-effective, without sacrificing anything in the controls. Next slide. So we take a big step back and we ask the question, well, why robotics and food and processing? Logical attributes, speed, accuracy, and longevity. It's a foregone conclusion that robots will last long beyond the legacy of the processing line. They are immensely accurate, many times more than what's needed. and the speed and repeatability of a robot can't be equaled by a human. So those are great attributes. But when we drill down a little bit further, we realize that there are a lot of other positive attributes for the consideration of robotics within a food or food processing packaging environment. The first attribute, and what customers realize is one of the advantages, is flexibility. Robots permit operators to allow the actual cell design to be redeployed, reconfigured, and flexible for setup and operation for programming, which means a very quick changeover, a very simple operation. The asset value of a robot is defined as a redeployable asset versus a fixed asset, which is a custom designed palletizer, case packer, picking scenario. A robot can be redeployed by simple programming and retooling to perform multiple tasks within an organization. Therefore, companies are realizing that they maintain an inventory generally of used robots and can redeploy them on a short-term notice for other tasks and other purposes. The ease of use of robots, the unified controls definitely provides an advantage for initial robot deployers and operators. However, even with conventional OEM robot language, robots have evolved into a very user-friendly environment where simple robot code can be learned in 3 to 4 days, and actually programs can be written within a week for a complete system. So robots have really gained a lot of ground in operator acceptance as far as a valuable tool within a manufacturing facility. The safety standards within the robotic industry have also evolved. The conventional safety standards allowed for a very, very broad spectrum of safety that sometimes wasn't operator practical. The new safety codes, which we'll talk about shortly, allow for collaborative interaction with humans to robotics. It allows for a very compressed working space within the confines of a robot deployment. So ultimately, the robot safety code is considered the highest level of operator safety because you can thoroughly disseminate stored energy, redundancy, and controls, so they are inherently very operator safe. Most robot manufacturers have also realized that there are fit-for-purpose designs that are a necessity based on customer demands, specifically in customer food washdown environments where operators need to clean on a daily basis. The robots need to be able to weather the corrosive and high-pressure steam washdown environments for sanitation. Robots are deployed in foundries, so there's heat, contamination levels. We deploy robots in a biomed environment, so they have to maintain a clean room standard. So gone are the days of a conventional generic arm that you try to deploy in a myriad of applications. Now we are very fit for purpose or application centric based on the nature of the design of the robots. The mean time between failure standard, which is a governor by RIA, which all of our robot manufacturers need to adhere to, provide for 60 to 70,000 hours of operation on a mean time basis between a failure. Therefore, they are considered widely the highest uptime rated device in any manufacturing facility. Next. So when we take a step further from the actual robot itself, and we've learned a little bit about the attributes and the benefits of a robot, now we want to drill down a little bit into understanding the complementary technologies now that have also evolved that are deployed and utilized within robot applications. The first being vision. 10 plus years ago, vision was deployed, but those who had worked with vision realized that it was a challenging task because vision requires lighting, it requires contrast, etc. The evolution and advancement of technology in vision have permitted cameras to be more intuitive, extremely powerful. But the tasks associated with vision have also required that they need to recognize parts and orientation, size the parts, understand if there's a defect, etc. The video will show us a little bit more how vision is deployed in a practical application. We're showing here is one of our Motoman partners who has developed technology for utilizing robotics for truck loading and unloading. If you can look inside the trailer, you'll see a myriad of different size cases, and the robot right there is executing a initial mapping task with vision and lighting to understand and see basically where all the grid coordinates are for all of those cases. Those grid coordinates are then very quickly and efficiently mapped to the robot control for trajectory execution. So the robot simply follows its, i.e. map of coordinates of all of the location of cases, and ultimately performs the task for seeking those particular cases in a very precise orientation and discharging those on a takeaway conveyor. So this is what's defined as a spatial vision, and this is one of the attributes where vision has really evolved from a 2D dimension ultimately into a 3D dimension. Thank you. As far as tooling, obviously robots have a kinematic profile like a human being. So again, we're migrating from the skeleton of a human and applying in simple relative terms, deploying technologies to emulate what a human does. So the next step would logically be the tooling, which is in essence our grasping hands or fingers, etc. Tooling has been very, very generic for many years. Vacuum cups, clamp paddles, forks for bags, maybe a stripper plate for cans. And certainly that's probably the 80-20 rule. 80% are generic tools and they work fine and they're very functional. But there's a lot of different technologies now in end-of-arm tooling that allow robots now to be deployed because of the tooling capability, whereas prior they inhibited the robot deployment. So the next video will show, again, just a smattering of some pretty neat technologies as far as the evolution of tooling. This is a tool by one of our partners called Robotique. This is a 3-fingered tool, and one of the advantages of this is certainly the dexterity. Each finger has multiple joints. It can work on multiple axes from either a side clamp or a collapsing multi-joint grasp, I should say. This has evolved into a similar type of technology. This is by Rethink Robotics, or Right Hand Robotics. This is actually a tactile feedback tool. If we look very closely, the actual fingers have a tactile feedback. The purpose for this would be to be able to grasp very light, very flexible, very unique profile parts. The tactile feedback allows the force spectrum to then be interpolated and commanded to apply the correct grasping force without ultimately crushing the product. This particular video is a micro belt swivel tool. This allows for showing an actual liquid or a foam, if you will, being able to be picked off of a bed and relocated without disrupting the profile. This again is just an example of an out-of-the-box type of tooling solution, but yet it does illustrate that with technology and with the emergence of product profiling, etc., we can develop tools for very unique product profiles and tasks. Software is ultimately the brain of the robot. The operating software from a robotic platform can be intrinsic to the actual product profile and path execution of the robot, but robot OEM manufacturers such as Yaskawa Motoman have evolved the software to provide for task-oriented software solutions. An example would be for palletizing, which we'll show on the next slide, where it allows for the actual robot execution to be pre-pathed and executed by the software rather than allowing the operators to command the pick points and the trajectory points. Motoman has developed what we call Pallet Solver. It is extremely powerful offline PC generated palletizing software which allows for the importation of palletizing patterns from third sources. We can assign cell obstruction zones, the robot tooling size, the actual zoning of the pneumatic tool is all pre-programmed. The simple operation allows for case sizes, length, width, and height, to be put into a GUI through the PC, so it's a very visual platform. The data will then be optimized and layer patterns can be created. And the final result is, from that point, the pick execution of the robot to the picked cases, the path trajectory, the velocity and speeds, and the entire pallet build is all automated via the software. There is virtually zero programming of points that's required by the integrator or the end customer. So this is an example of a task-specific software solution that eliminates the heavy burden of actual robot programming, and it's simply inputting data into a PC, and the entire robot kinematics are pre-programmed and executed. Next. So we've talked a little bit about the actual software in the brains of the robot, the tooling for the robot. The next logical execution of technology is mobility. Robots 95+% of the time are static deployed, which means they're mounted on a pedestal or inverted. But the technology now is lending itself to the deployment of robots to serve multiple machine cells or multiple pick points via conventional portability methods. And there's many operations now that are utilizing AGV type of vehicles to move robots into certain work zones. The video coming up will show an example of this. This is not food per se, but this is something that recently has been developed by Yaskawa Motoman. If you look closely, you'll see one of our dual arm robots tending to multiple machine cells, but you'll see the capability of the robot then to be relocated from point to point, self-docking, and then performing its multiple tasks, taking advantage of the ability to use one robot for a very wide physical space of operation. Safety is a necessity, and we are not only governed by RAA as far as safety standards, but safety is probably preeminent within Yaskawa Motoman. The fortunate advantage for the dedication to safety is that through RAA and ANSI, there have been an involvement of safety tools that permit robots to work in a collaborative fashion with operators, programmers, etc. There's a couple different definitions of collaboration. One is speed and separation. The other is force limiting robots. But ultimately, this allows for the safety fences to be in a very compact method. It allows for operators to actually enter the work cell, and the robot will then enter into a safe working speed with a separation of distance between the operator and the robot. The force limiting robots that are much smaller capacity and a little bit slower operating allow for tactile feedback through the force limiting features that they possess. So if an operator reaches in and the robot arm is on a path and touches the operator, it will stop in a safe mode or a safe speed. But the summary is safety is emerging, it's evolving. ISO is performing some additional testing in Europe as we speak to determine what's defined as the anatomical correct torso forced pain thresholds. And what that means ultimately is that as we begin to see safety regulations continue to evolve, we'll begin to see robots become more and more collaborative and interactive with humans. Next. So when we start now drilling down to the ultimate purpose of our dialogue today, we want to take a look at where robots are deployed from processing through primary packaging, ultimately into secondary packaging. Next slide. At the front end of the line of processing, when the raw materials are introduced into an environment, we begin to see that there is a demand for some type of automation, obviously because of the labor aspect. But one of also the current drivers for looking at automation and processing is the Food Safety Modernization Act, or what's referred to as FSMA. This has been released in 2014. Next year and the following year is the scheduled final implementation. And it's really changing the landscape for food and food processors, which most of you, I'm sure, are very much aware of. A typical example of a solution for robotic automation in processing, one of our partners deployed Motorman arms with stainless steel hydraulic shears for the actual processing of livestock. There would be an inspection process. We would track the actual carcass, and limbs or primary cuts would be utilized via vision and a technology of path following through the robot to actually process and do the initial handling of the actual food product in preparation for the next steps. But I'm not going to show you that video today. It might be a little bit hard to watch, but we've got a couple other good videos coming up that will show some examples of robots in food processing environments. In the primary side of packaging, automation is certainly, as the slides indicated earlier, on a track for escalated growth. Primary packaging is defined as picking the raw material, putting into the primary, could be a sleeve or a carton or a case. But what's required in primary packaging is generally speed, orientation of the product, because they're coming out somewhat random through your initial food processing, could be ovens or chillers or IQF, and also some inspections of quality and orientation. The video coming up will show some great examples of primary packaging. What robots generally do an excellent job at is understanding motion control, path following, and orientation. This is a good example showing primary picking of products from an in-feed belt, relatively random, but reorienting them and putting them into pockets for flow wrapping or over wrapping. This is a tried and true method of solutions. You can imagine how many hands would be required to do that function. This is a really neat application. This is frozen ice cream cones that are packaged and ready to be put into cartons. The profile of the cone is challenging. It's a tapered cone, it's round, but yet it's not consistent from head to tail. High-speed Yaskawa Motoman Delta robots are performing the picking and task executing. We do zone to zone to zone balancing through the 4 robots. So you'll begin to see how we transition product from zone 1 to 2 to 3 to 4. But the picking sequence requires the products to be alternated and nested within the actual cartons. So you begin to see how fast that can be performed and how accurate and consistent robots can perform primary packaging by placing alternating goods into the cartons, ultimately down for secondary and final completion for packaging. Secondary packaging is what we've all know that it's been very common deployed in robotics. Palletizing, maybe case packing, probably 20 to 30 years we've automated that function. But there has been a change, and the change was driven by the sustainability efforts within the supply chain. More and more manufacturers are driven by the need to reduce the actual packaging content, to have dynamics associated to the types of products that you fill or package your products in. The bottles, the containers, the shapes are infinitely changing. All those supply some challenges for packaging and for automation. The videos coming up will show a couple good examples. In secondary packaging, now we've got the product in a bag. We can pick, track, nest, cavitate into what's called a display case. Packagers don't really like this type of case, but obviously sustainability is driving that. It's a point of purchase display. Sides are open, tops are open, but again, we have to pick that on the fly. As far as an example within a plant for secondary packaging, this is cheese. And you begin to see that robots can do some very unique tasks. Here we're picking up large wheels, placing them onto an actual shelf for another process. But you'll see shortly how robots can collaborate with each other based on a need for reorientation. So we can have one robot hand off to a second robot in a collaborative workspace with high accuracy and perform a secondary task. This particular example is showing bags of potatoes. Again, very shortly after they've been processed, cleaned, and packaged on the primary side, but then ultimately being unitized and accurately placed into a Gaylord container for final shipment to customers. Take a look at the tool. That's not a common tool that you'll see everywhere, but again, it's fit for purpose design for that application. And that's the summary of today's event. Greatly appreciate your time. We welcome your participation with any further questions through ET Accelerator. Be more than happy to address those. And I'd like to extend an invitation to the participants. We'll be exhibiting at PAC Expo in Chicago, November 2nd to the 5th. Please feel free to stop by and visit with us. There's a lot of neat technology that we would be welcome to share with you, and hopefully you'll learn a little bit that you might be able to successfully apply and deploy at your facility. Thank you very much.
Great. Thank you, Jack. And Jonathan, Ken, Charles, are you folks on the line? Oh, there you are. Yeah. Any questions for Jack?
It's Charlie. First of all, I thought it was a great presentation. I just want to make that comment. One of the participants asked about training, and you just put out a kind invite for visiting your place and the trade show. You have any other thoughts on training?
Absolutely. Training is one of the key elements of any type of robotic application, especially if it's a customer that has a new robot and takes the first robot in their manufacturing facility. At Motoman, we believe in a very hands-on approach to training. We have a 2-to-1 ratio, so when a person comes for training, he shares a robot with only one individual. And it's an AEC accredited training program, so you'll get college credits when you go through 4.5 days. We have about 80 robots in our training facility and professional trainers. We can't speak enough for how important training is. It's kind of fun to go through. You'll really get a mind meld. You'll learn a lot. You get a very nice curriculum. But because robots are here to stay, the more cross-training, we have customers that come every other month, and they'll send teams of groups for training. So it never ends. But Charlie can't underscore enough how important training is.
You know, one of the attendees also asked about where to get some more videos on tooling. That is, YouTube is a great resource for not everybody. I think all the robotic manufacturers and integrators like yourself certainly put quite a bit of videos, quite a bit of effort into our videos to demonstrate the applications that have really been done. Wes just asked a question about bakery products, cakes. Personal experience, we've done applications where picking and placing of candies that are just kind of fresh out of the candy making process. So there's YouTube's a great place to see those applications as well.
Great. Yeah, Ken can't give himself a plug, but I'll do it. They've got on Bastian's website some tremendous case studies. A to Z, they explain what the customer's issue was, how the problem was solved. I'm sure ABB has similar stuff.
Thank you, Charlie. I appreciate that.
So I think that's about the end of the day for us. I want to thank our panel.